Hi, I'm Sahani. You may remember me from such educational films as Lead Paint, Delicious but Deadly, and 2 minus 3 equals negative fun. But today I will be discussing the point of the Sharpe ratio. Sharpe ratio was developed by William F. Sharpe, who was born in 1934 in the city of Boston. Is that State Street? William won the Nobel Prize for his pioneering work in the theory for pricing of financial assets, including developing the capital asset pricing model, also known as CAPM, and the Sharpe ratio. The ratio is used today both on Wall Street and Main Street. It characterizes how well the return of an asset compensates the investor for the risk taken. It is thus classified as a risk-adjusted measure of return used to evaluate performance, including the performance of portfolios and fund managers. When comparing two assets versus a common benchmark, the one with a higher Sharpe ratio provides a better return for the same risk. It measures the excess return or risk premium per unit of deviation in an investment asset that tells if a portfolio's returns are due to smart investment decisions or just a higher level of risk. Thus, it can be calculated by the following formula. The Sharpe ratio equals the excess return of investment, that is the average return on an asset, minus the risk-free rate, divided by the standard deviation of the asset's returns. Let's now look at an example of how the Sharpe ratio can help structure a good portfolio.
The following is a 5-year price history of Apple, American Express, Emerson Electric, Express Scripts, and a Vanguard ETF that tracks the total stock market. With this 5-year price history, we are able to calculate monthly returns using the ln function. After finding monthly returns, we can find the beta of the returns by using the slope function of the asset over the Vanguard ETF. The mean return is just the average return of that asset. After calculating the mean return, we can then calculate the excess returns by taking the monthly returns and subtracting them by their mean return. These excess returns are required to calculate a covariance-variance matrix, which is simply formed by matrix algebra. The betas here are simply the betas that we had found earlier. The monthly return on the market is the return that we found from the average mean of the ETF. The monthly risk-free rate we assumed to be 4% a year and just divided the rate by 12 for simplicity. According to CAPM, the risk-free rate plus the beta of an asset multiplied by the market risk premium gives you the expected return on the asset. From there, we take our stocks and we just assume some weights. These are just made up. So I just did 0.9, 0.01, 0.01, and 0.08 to make 100% for a total weight in portfolio. These are the expected returns that we had calculated earlier through CAPM. Down here is the information that is required to calculate the Sharpe ratio. Notice that with these weights, the Sharpe ratio is 17.5. We can use Microsoft Excel to develop a better portfolio that will have a higher risk-adjusted return. To do this, we need to use the solver function. Using the solver, we can set the Sharpe ratio to equal its max by changing the various weights of each asset, subject to the constraint that the total weights must equal 100%. Hitting solve, we see that the weights of each asset has changed, but still adds up to 100%. And in fact, Sharpe ratio has increased by at least 11%. We have thus found a portfolio that produces a better return on a risk-adjusted basis.
As we have just seen, the Sharpe ratio can play an important role on investment decisions. The Sharpe ratio, a measure with a point.